So, Abdalil, Abdalil, how are you?
Yeah, I'm fine. Thank you. Good morning.
You okay? Yeah,
Yeah, I'm good. I'm all right.
fantastic, fantastic. So, yeah, this is the last session. I mean, is there anything that you want? Excuse me, losing my voice. Is there anything that you'd like Abdul to cover? Anything that you want to say at all?
I just want to thank you for for giving us this opportunity to learn all these things right from the time you started. So most times I always join and drop off, but I always try to like watch the recording. So I just want to thank you most especially and the tutors that have been taking us right from the onset.
Fantastic. No, that's good. I'm glad you got value out of it. Was there anything in particular that you liked or that's helped you? Any particular week or any particular subject from the syllabus that you got most value from?
Yeah, sure. Yeah, sure. Yeah, I've been opportune to actually use some of the things I've learned in my day-to-day life, most especially in my current master's program. You know, having to learn Python in class and also learning it here has been beneficial. Learning from somewhere is like apart from what you've been taught in class. In terms of masters, they don't really put our hand like that. It's just like, okay, just take these resources and just go and learn it. But for this one, there's like the practical aspect of it that we tend to like do more hands-on training. So for that, that's really been beneficial for me.
Fantastic, fantastic. That's good to know. That's good to know, buddy. Good to know. Thank you.
Okay.
Checklist, how you doing,
Yeah,
buddy?
I'm good. Yeah, good.
Yeah, you had a good week, yeah.
Yeah, it's been good.
Fantastic. So yeah, and the same question to you. Anything in particular that you've learned, the sort of value, any particular part of the syllabus that you found really, really valuable?
Yeah, every part of the course so far has been very useful. And again, yeah, I've been very confused about data engineering, but the explanation Abdul gave the last time he talked about data science, data analysis, and the differences and where they come together. So I asked him a particular question, what exactly is data engineering? And he was able to explain to me that, he gave an example. He said if you have like weight and height, combining the two and doing whatever manipulation you have to do to get your BMI, that's a good example of data engineering. So yeah, that
Good.
alone clarified a whole lot of confusions I've had in the past. So yeah, is one thing I picked. And I am trying to get back into data. I'm in the UK now. While I was in Nigeria, I was formerly in a data analyst role with EEDC. So yeah, coming to the UK, I found it very tough, getting back into data because of the skill gap. But so far, I've been able to learn SQL, Tableau, Power BI, and this is a great opportunity for me to also add Python to the whole skill set. So yeah,
Yeah,
it's been
uh,
very beneficial to me. Yeah.
definitely. Yeah, I think Python's essential. SQL, Python,
Yeah.
because obviously I'm a recruitment guy. And so speaking to companies about their jobs is something that I do on a daily basis. And I mean, the first thing they say is that Python, SQL, or R is the essential foundation for you to develop as a data scientist or data engineer or
Yeah.
even as an analyst to be able to manipulate the databases. As an analyst, you need SQL. So yeah, that's fantastic. Fantastic news, or fantastic feedback. So thank you very
Thank
much.
you very much. Yeah. Thank
Yeah,
you.
well, basically, I'm not the one giving you the because I'm not the academic here.
Yeah.
Abdul's the one who's been.
I'm very grateful Abdul could, squeeze out time from his very busy schedule to, handle us in all these Python classes. Yeah. I really do appreciate that. Abdul, thank you for
Yeah,
what you've done. Yeah.
you're welcome. You're welcome.
You're welcome. Yeah.
Fantastic. And Alex, anything that you want to say, or you want to see Abdul to cover again today? We're going to go over quite a few bits from the entire program. Is there anything that you'd like to cover?
All right.
How you doing, by the way? You right?
Okay, please, can you hear me?
Yeah. It's Ian.
I'm good. And you too?
Good. So yeah, just saying, is there anything that any feedback?
I also want to say that this personally, I already had a skill set in Power BI, Excel, and then Tableau, and a little touch on Python when I was doing my master's program. But this program has
You break it up, Alex.
an in-depth knowledge in
the connection's breaking up
to manipulate data, and also especially using Python for machine learning modeling. It was something that I really wanted to learn. Is it okay now?
Yes, much better. Much better.
Yeah. So so the aspect that I really enjoy from this program is the machine learning aspect. Even though I have some knowledge in using Azure Machine Learning Studio to develop a model for testing and all of that, I find it an additional knowledge with using Python also, which currently is very, very essential in the data ecosystem. So I really appreciate this program. Thank you, and then our instructor for giving us such a deep knowledge into the data profession program. But what I want to find out is that the job opportunities, is it there for only the community members who are in the UK, or what about some of us who are outside UK? For me, for instance, I mean, in Ghana.
Yeah, no, I love Ghana. I was there way back. I was in Accra. I love Ghana, man. I stayed at Labadi Beach. But anyway, that's a conversation for another day. But in terms of job opportunities, the majority of the companies that are recruiting, they're recruiting individuals that are based in the UK. And there's nothing I can do about that. Because the way the job market is now, in the digital sector across the whole, like for developers, cybersecurity, data, etc., it's very, very tight. So there's a lot of candidates in the market in the UK that are looking for work. So it's a lot easier than it was for companies to hire people now in the UK without having to have the extra expense to sponsor somebody. So I'm not saying it's impossible. Okay, some companies will do it, but not many at the moment are doing it because they don't need to, because they have surplus people here in the UK to hire. And it's a really, really hard thing for me to say. I don't like saying it, but I'm just being very honest with you. It's really, really hard. It's just really difficult, really difficult to get sponsorship. It's not impossible, but it's very, very hard because a lot of companies don't want to do it if they don't need to do it. So maybe in the near future I see things changing. All I'm doing, by the way, Alex, I'm just giving you my opinion because I'm speaking to companies on a regular basis, and they are looking to sponsor at the moment. I don't know. I haven't spoken to any employer currently that wants to sponsor or has a need to sponsor. I am seeing more jobs coming available, which is good, compared to the beginning of the year. So, but yeah, but it's not as loose for candidates as it was 18 months ago, 2 years ago, when there was a bit more. There was a big hiring. Everyone was hiring crazily. You know what I mean? It was mad, and so there was a bit more movement in the market. But right now, it's tightened up significantly. So yeah, you know, I'm really sorry about that, remember, I'm just being honest. Do you know what I mean?
Ian, can I please add to that, just from a kind of AI angle, and globally as well, and from a sort of compliance, regulation, and legal point of view as well. What I'm seeing is that, obviously, well, what we're all seeing is that AI is growing. Yeah, many businesses are globally. Many businesses are, you know, joining that journey, and they, you know, kind of somewhere along the line, they will recognise that tidying up their data, the need for DAs, data analysts, data engineers, data scientists, is increasingly essential as they mature their AI, as they mature on their AI journey. So I suppose what I'm trying to say is, you know, outside the UK, with the growth of AI and with the growth of data legislation as well, globally, Nigeria, the Caribbean, other places in America, you know, other places outside the UK, all I'm saying is there is hope for
skills
members
to be utilised globally.
Yeah, absolutely, absolutely. So don't just, I suppose my plea to those outside the UK is, don't just rest all your hope and all your laurels on UK data opportunities.
That's a very good point.
With AI growing and with data legislation growing globally, those two things are going to generate data opportunities globally.
I have to agree, 100%. I mean, it's a new currency. Data is a new currency. It really is. I mean, you know, it's 15 years ago, no one understood the real value of data, and it's just grown in terms of positions, career, job titles. The value of data has been recognized, just from even just to analyze data. Companies weren't analyzing it 15 years ago, 12 years ago. Now data analysts are part of every company. They look at the data to analyze the growth. Where's our growth coming from? Where are we losing money? They dig into that a lot deeper than they did before. The data visualization, the Tableau, Power BI, all those tools are now being part of smaller companies. Before, it was just, you know, the larger companies that use those sort of tools and skills. So without a doubt, I think data as a career is on the up. It's increasing. There's, you know, and AI is, as you said, crazy.
Yeah.
In terms of it being used. But in terms of the UK market, you know, there has been a bit of an upturn in vacancies.
Yeah.
But there's a lot of people looking for work. There's so many people looking for work, and it's just, you know, companies they do sponsor people, but there's not as many people that are sponsoring. Sorry, there's not as many companies that are sponsoring as there were previously. It's the same thing with remote working. More companies going for the hybrid model, where individuals work 1 or 2 days in the office. 2 years ago, people were working remote all the time. So things just change. They go up and down, and I think it will come back in terms of where there'll be more sponsorship opportunities, but it's just not as high as it was 18 months ago. Alex, anything to comment on that?
Yeah, thank you for the explanation. I'm grateful.
Do you know what I mean? Yeah, I think, you know, just trying to think of other ways to leverage the skill set and your passion for data in Ghana. But maybe you've already done that in terms of reaching out to government bodies, reaching out to the type of companies that you want to work for and say to them, look, you know, I can work for you on a freelance basis, or even take a bit of sample, do a bit of sample work for them and present it back to them so they can see the value of what you could do. But maybe you're thinking, Ian, shut up, I want to work in the UK. And if you do, fair enough. But to get your foot in the door, to get more experience, then maybe, you know, offering your skills as a freelance in Ghana, maybe that's something that you can consider doing. Do you know what I mean? You know, I'm just trying to help, man. I'm trying to help. Do you know what I mean? But I haven't got the answer. Cool. All right. And look, enough of me waffling on.
All right. Thank you.
No worries, buddy. Just reach out, and also any questions, Alex, if I can help you, man, I will. So just ping me a message, and that goes for anybody. If I think I can help, what does Ian think about this, or what? Just ask me. I don't always have the answer, but I'm here to help. As you know, we've got the CV database. As you know, we've got the job boards. We've got the academy with Abdul that you're in. So we're just trying to add new layers of BDPN help as a community, as a network. So that means as well that you can reach out to me and say, ask me a question. Okay. Anyway, it's the last session. I'm going to be back on. I've got some stuff to tell you as well at the end. So I'll be back on at the end with some bits and pieces to tell you all. And I'm going to hand over now to Abdul. So cool. Enjoy. Cheers, guys.
Yeah, good morning, everyone. I'm happy to be here once again. And I hope after this lecture, we're going to be having some, maybe occasionally, there may be a call for maybe a 1 hour, 2 hours, occasional review together. Perhaps we'll just pick a data and look into a particular data and start from the point of data processing up to building the models. So we can be choosing a specific data from different fields. So it's going to be the last section for this particular cohort, but that doesn't mean that the community stops. I believe the community is going to continue with time. We have lots of programs to do together. And I will be happy to see any one of us hosting us, or sometimes I may still be called to host the program as well. So I hope we have a good relationship as we go together in this journey. Now, today we are going to recap everything we have done from the beginning to the end. And I will share my Google Colabs with you. I already have some things I put together so that it can be faster than just typing them. So let me share my Colab. Can you confirm you see my screen?
Yes, seeing your screen.
Okay, thank you. Now, initially, we started from Python basics, the basics of Python. Then under this, we talked about things like the data type. And on this data type, we discussed the different data types we have. Notably, we talked about the string, the int, we talked about the float, and then we try to classify them such that we have other form of data type like complex. We also talked about list, tuple, set, and dictionary. But I believe we use more of list and dictionary. We use more of list and dictionary. We talked about the different methods, append, this and that, different stuff. So, which we eventually begin to use the dictionary to create a data frame. And at the same time, we also use our list to create a data frame. So we basically talk more on dictionary and list, or we use more of dictionary and list. The Boolean majorly used in control. If you want to use if control, the other control flow, we can use Boolean to check out some of the condition. And then we also know that we have in our data frame, we can have a data frame that is of ints, a data frame that is of floats, and then we know how to convert from one from one data type to another. So those are the initial things we look into. But of course, that was not our focus. Our focus was to actually look into data. So because of that, we utilize more of dictionary in an list. For example, if we want to create a data frame, we can say maybe data is equals to a particular dictionary. We set a dictionary, and then we can say male. For example, there'll be 5, female, and like that. So when we create like this, it's a dictionary. We can make this dictionary to become a data frame. So all we're just going to do is to call on pandas, which pandas is one of our data frame. We can call on pandas, which is one of the libraries that we use. So if we call on pandas, we can simply say, making this to become a data frame, we can call it the F, for example, the F to be equal to the pandas data frame. I call it date. I want to call it data rather. Data. If I run this, it's definitely going to run, and I will have a new data that contain male and female. So in form of a data frame. However, if I've never called the dictionary in the libraries pandas, this may give me an error because I have to first call on pandas or import pandas like this. If I say import pandas as the L, that is the first thing, as PD rather, that is the first thing I must do. So now, because I'm calling on pandas, I don't actually mean to use these. Okay, let me just copy all I've done here. I opened, okay, I think this is what I want to use. Okay, this is what I want to use for today's lecture. Yeah. So I must call on my various libraries that I need to use before I can begin to use them. But let me quickly copy all this into what I plan to use so that, okay. So if I call on this data frame, the data is going to print the data frame for me because I already called on pandas. I already imported pandas. So if I run it, oh, what is the error? Where is the error coming from? Okay, yeah, because I said may and I did not quote it. It's going to be a problem because it's a string. So if I run this now, I should be able to have a data frame. Okay, I didn't put comma. Yeah. So what happened? I already have my data frame. If using a scalar, you must pass an index. Okay. What is the problem now? I run my, so I actually want to run this as a data frame. Maybe if I say, let me see the other parameters index. Why is this giving me a stress? Okay. I run the dictionary first. After running the dictionary, I want to use the dictionary to call for a data frame. Let me just call it the F is equals to data frame. Then I pass the data. I run the data, but it's giving me an error. I'm not supposed to be getting this error. Okay, the index for it. Okay, index is equals to, that is going to, index is going to be the one that will serve as the, let me just call it 1 and 2. Okay, 0 and 1. And run. Okay, let me call for the df and run. This is just by the way. So this is what I have now, just calling for the index 0 and 1. So male and female. Under male, I have 5, 5, 10, 0. Okay, but because I was using to index anyway. Anyway, this is how we can create a data frame from a dictionary or from a list. We can create that, which we have done. These are not our target. Our target is actually to get this data, and getting the data is the major issue we faced initially. We're asking like, where can we get this data from? The data can be gotten, let's talk about the data now. So we say the data can be gotten from different places, like data. This data, we can get this data from web, by scraping the web. We can get this data from database by using SQL to call it. Another thing we can get it from file, either Excel. We have different files. It can be Excel file. It can be CSV file. CSV file, and etc. So these are different ways where we can get our data from. Now, having gotten the data, what is the best thing we can do when we get this data? One of the things we can do after we get the data is to, because I'm not using it here, is to clean the data. We have gotten the data. So after getting the data, the next thing we do with the data is to clean this data. And talking about the method of cleaning this data, we discuss these procedures. We say, if we want to clean our data, we can do the cleaning, the data cleaning using initial data processing. We process our data. Another thing we can do is that we can find for the missing value. And we can also find the duplicate, and we can also look for the outliers. Those are things we can do on our data. Now, when talking about the processing of this data, there are some processing that we basically do. Some of this processing we basically do when we are doing the processing of the data. We do processing of the data, we look for the missing values, we do we look for the duplicates, we check for outliers. We say why we are doing the data processing. If someone is let's say someone is talking, please.
Noise, background noise somewhere. If you can mute, everybody can go on mute, please.
So talking about the data cleaning, we say we can do data pre-processing. We can do look for missing values. We can look for duplicates, and we can also look for outliers. But in the name of the pre-processing, some of the pre-processing we can do, let me just call it, well, I call it inspection. Let me call it the pre-processing. Some of these processing we can do, which I also want to call an inspection here, is data type mismatch. If we have some data type that are in an integer that are supposed to be in float, we can convert them to float. So, which I believe we already know how to do this conversion. There are sometimes we have labeling error. We can replace, if we have some labeling errors, especially in categorical data, someone says male, and if you check it again, you have another version of male, and maybe another version of male like this, in the same data. So these are labels that we have to correct. We have to correct this using replace. So there is a way we can, because it should rather be, this should either be male or female, but when we begin to have different variations, then we have to correct for that using replace method. So irrelevant features, if we have irrelevant features, we can remove them. So when you have something that you think they are not necessary, especially you can have a features that is common for everything and for every data in the column. For example, if you check a particular data and you see that a particular column is just general for everyone, so that data is going to be irrelevant. You check column 1 and you see that particular data has a particular value that is the same thing for every row, then it means it has no relevance there. Then we can remove such a data. So those are the things we do when we are doing our cleaning to prepare our data for machine learning. The other thing we still do, we do some visualization. I want to say we have, well, I want to, in my own words, I want to classify this visualization into two. There are some visualization we do to be able to communicate to maybe people that are non-technical. We just want to communicate and say, okay, as you can see, to give the insights from the data. That is a category of visualization we can do. When you run such a visualization, you want the audience to see what is in the data, to present the insights of the data. For example, you want to say the male are more than the female. You can just plot a bar chart. So when you plot your bar chart, you're gonna see the column of the male that will be longer than the column of the female. Such is just for communication to the non-technical individual. The other type of visualization that we do is the one that is meant for you yourself, not for anyone. It is actually meant for you to be able to get some insight from the data, to be able to fine-tune whatsoever machine learning you are building. Or you want to see, for example, you don't present your bus plots to that is indicating an outliers to your to the non-technical audience and say, oh, from this you can see from the bus plot, you can see there are some outliers, there are these. Those are meant for you to be able to correct your data, to see whether you are going to remove some outliers from the data or not. It is meant for you. Or you want to do some some plots to see whether the data, they are symmetrical, maybe normally distributed or not normally distributed. Such are meant for you to know what to do with your data, how to modify your data the more, whether there are some features you have to modify or things like that. Those kind of visualization, they are meant for you as a data scientist to be able to have a better models. So when you talk about this visualization, you can just divide it into two. Some visualization are meant for the audience, while some visualization are meant for you to understand your data better. Now, I want clean your data, do some pre-processing. You want to check some EDA. You want to explore your data. So you can explore the data. Sometimes it is during the exploration of the data that you get to know what to process. In fact, the explorations will even come before the cleaning. So I will say, before data cleaning, we actually have to do data exploration, EDA. So if you do your exploration, that is when you know some things you have to do with your data. For example, you can say the add. You can call for the .add to check some of these features. You can call for the describe, the app.describe. You can call for an info and so many other things. All these will help you to understand your data better. So once you understand the data, that is when you are going to know, oh, we have some mismatch labels, we have some outliers. In fact, if you call on your describe, you can actually know whether you have outliers in your data or not when you check the statistics. So there are things you can check during your EDA that will help you to prepare and clean your data better. So I want to say the EDA will come before the cleaning. So those are one or two things we have done. And now we are going to take a particular data that we have not used before during our training and quickly do a lot on the data. So I took, because I see the data is simple. Why I choose this data is because someone was asking that after building our model, how do we deploy the model or how do we use this model? We have prepared a model and the model performance, we have checked the metrics and we say like, okay, the model is 70% in accuracy. The model is 60% in accuracy. Some people will say a model from 70% accuracy is a good model, but depending on the data or on the field where you are using it. If it is something that have to do with life-threatening, you may not want to take a model that is 70% in accuracy. So on accuracy, you may not want to take that if it is something that is life-threatening. So you don't want the 30% chance. You don't want to take that chance. So when you have a model that is 80%, it's better. Now, when you have a model that is 90%, the higher the accuracy, the better it is. But in general, a model from 70% is a good model. It can give you a good prediction. So now we want to take this diabetics data, which I already have. So what you do is a CSV file. Once I run it, I got this. When I check the head, this is what I have on the data. Of course, the data can be an Excel data, it can be a CSV data, it can be a data you scrape from the web, it can be a data you pull from a database, through your SQL and stuff like that. So, but this one is already in CSV file. I already put it here. You know how to input on your collab. So I already have the data. So after running this data, why I was using this data was because the inputs are not much. We can easily guess on this. So that is why I just decided to use this. However, this data at the same time is gender sensitive, because when you have a data that is asking for pregnancy, you should know that this is only meant for female. So if you say number of pregnancy, you say 1, glucose level, body blood pressure, skin thickness. Of course, you may not know. It's easier to know the number of pregnancy. You just ask how many pregnancy have you gotten before. So one can actually say, okay, I have never been pregnant. Oh, I had like 2, 3. When you talk about the glucose, of course, you can measure that in the hospital. Some of you can have some instrument you can use to know your glucose level. Your blood pressure you can know, but depending, I didn't read the description of this, because the blood pressure may be the systolic or the diastolic. So I don't know the one that has been used. Let's just assume the addition of the systolic and the diastolic divided by 2. So it can be either systolic or diastolic. I don't know the which of the blood pressure that has been used. But on assumption, we can believe that anybody, you already know your blood pressure. Just say maybe like 80, 120, 90, depending. So your skin thickness, of course, you may not know how to measure the skin thickness, but of course, you go to the hospital, there is a way they can measure it for you. I don't know how to measure the skin thickness. There's definitely going to be an instrument for that. The insulin level, there is a way, there are instruments that can be used to measure the insulin level. So which, of course, you can know your insulin level if you go to the hospital. The body mass index, you can measure your own body mass index by yourself. Body mass index is simply your weight divided by the square of your height. So if you know your weight and you know the square of your height, you can actually calculate your own body mass index. So it's easier. This one is easier for everyone to get. And then the diabetic pedigree functions, there is a way it is calculated. Anyway, I don't know. I think they used to ask the history, like if your father has this, or your mother has a diabetic, or this like that. So, or is there anyone in your family that has a diabetes? So I don't know how they calculate it. So when they get those data from you, they can actually calculate the diabetics and pedigree. But I think, I don't know, I think the higher it is, it means you have a lot of this history in your family. Like someone that has 0.351 may have a low history of diabetics in the family. And I don't know how it's calculated, but let's just assume that we can easily get it. Of course, your age and the output 0 and 1. This is a classification, a model. If we are going to build a model for this is going to be a classification model, a classification data we already have. It has been classified into 1 or 2. 1 which will represent someone as diabetics, and 0 which will represent someone that does not have a diabetics. So this is actually a classification of binary classification, just 1 or 2. You could have some other classification that will not be binary. It may be like up to 3, 4, like high, low, and medium. Like that, you can have things like that. So, but this is just a binary 1 and 0. So which one, I want to assume that the 1 represents those people that have diabetics, and 0 represents those that do not have diabetics. So this is just the 5-column column on .head, but I want to know how many are they, how many columns do we have, how many rows do we have? You have 768 rows and 9 columns. Well, there may be a little problem with this data, because if we have like 9 columns and we are having 768, the data will not be enough for training. This data of 768 and 9 column will not be enough for training. Please, who want to tell me the reason why I assume that this data is not enough? Let someone, because I mentioned it during our class, the criteria to know whether the data will be enough for a machine learning model. So, which one did you think? Why did you think I say this will not be enough to train a good model? Of course, it's going to train a model, but it's not enough. Why? How did I know? So let someone quickly just tell me why this will not be enough to train the model. Anyone? Okay. If
So
not,
you mentioned the number of rows and columns.
okay. So why is it not going to be enough to train the model? I already have 768 rows rather, and just 9 columns. But yet, I still believe this 768 is not enough. It's not enough data to train a good model. Why? That is the question. The reason is because we already have 9 columns. And according to the rules, for you to have a good training, your number of rows must not be less than 100 multiplied by the number of columns. So if I am to have a good machine learning model from here, I should have nothing less than 900 rows. It's just going to be 9 times 100. That is 900. Instead of 900, I'm having 768. There is a little problem I'm seeing. This data is not enough. It's not enough. It's going to train, but it's not going to perform well because the more data you see, the more performance the model is going to be. It's going to give. So if you have 768 and you have another data that have 9 columns and then like say 1,500 rows or 8,000 rows, that will perform better than this because the number of features we are combining is 9, so we should expect more columns. If we have just like 6 columns now, it means that this is enough because we already have 700 plus, so which is enough for a 6 row in column. But for a 9 column, this is not good enough. Anyway, that is still what we are still gonna use. But I can see that this is not going to perform up to our expectation because the data is not enough. Part of the thing that affects the machine learning model is things like the volume of your data. If the data is not enough, is going to affect the outcome or the performance of the model. Another thing that affects the machine learning model is when you have a categorical data, like for example, under the outcome now, instead of having 1 and 0, assuming we are having yes or no, there are some model that will not perform on such categorical data. So we have to convert them back to a numerical. That is the reason for some conversion. But everything has been converted here. So we don't even need to convert anything. Like when you have outcome and under the outcome, assuming it's yes and no, we can use so many things to convert it. We can use label encoding, we may encode it. We may use a mapping to encode it, and logs. There are some other techniques we can use as well. Okay. Anyway, we're still on this. This is not going to be good enough because it's just 768 out of 768 rows to train 9 columns. That is not good enough. So we already have a problem with this data, but no problem. Let's continue. Now, let's look into the info. From the info, we can see that when you call on the info, you can see if this is having of course it's still 768 and 9 columns. But if you check them one after the other, you can see that pregnancy is integer, glucose is integer. Yeah, all of them is good on their being integer. BMI is flowed, which is good. Diabetic is this. Okay, they are all good. There's no mismatch. Assuming it's not we have mismatch, what we are going to do, we just convert from integer to float or from float to integer. But there is no need for that now because I think they represent very well. Now, the other thing we can check here, we can see that even without calling for the non-value, you can see that there is no non-value here. This is 768, 768, everything is 768. So there is no missing values from this data. It's like this data is free from the missing values without even calling on that. But by the time we call on that, eventually we are going to see that there is no missing values. So, well, it's like I call on, okay, well, I can't find it. Let me just call for it for now. Let me create a column. Let's just call on the f dot, what are we calling now? We want to call on, you see, non-value. Yeah, let's call on the f dot non. The f dot, NaN is non. It's not. So when we call on the f dot is not, so if you run, this should give us 0 because checking on the info, we already see that. So let's check for that, okay? So you can see everything is 0. There is no one that has a non-value. Assuming there is anyone that has a non-value, we already know how to do that. We only replace, either we can replace with building using main, we can use mode, we can use median, depending. We can use we can remove the non-value if we have a voluminous data, but for this kind of data, we cannot remove because it's not even enough, so we better compute for it. We can use any random value if we think. We can use feed forward, feed backward. Those are the way we can replace, assuming we have anyone that has NA. We can replace the NA using, we can remove the NA or we replace the NA. And when we want to replace, there are things we can use to replace. We can use mean, median, mode. We can use feed forward, feed backward. We can use interpolation. Those, and I told you to use interpolation. Interpolation is meant for time series data. So we use interpolation for time series data. So it's not this kind of data we use the interpolation for. So, but if there is no NA, no problem. We continue. There is another way we can check for our NA. We can use an heat map. When you use the heat map, you are going to see whether it is clean or it's not clean, and then we'll be able to do that. But since there is no NA, no problem. We already checked. Now, we call on our describe. In the describe, it's just a statistic giving us the statistic of the numerical data. If we want to call for the assuming is not only numerical, we can.
Sorry.
Yeah.
Sorry, Abdul, please. Sorry to interrupt you, but I want to ask one question.
Okay.
In real life, like in actual data analysis, if you have missing values, is it okay to fill it up with either the mean or you do the interpolation when you want to really get results?
Yes, yes. It depends on the data. If you have data that is very voluminous, you understand, you have a very voluminous data, what you can do is to just remove it. But even if it is a real data, it is easier for us to input. But before you input, there is one principal thing. You must have domain knowledge to input. For example, you are working on a particular data that you don't have an idea of what the data is even talking about. You are not sure whether you are to use main, median, or mode, or you have to use what do I call it? Interpolation. Yeah, just remove it. but it is very good if you have a base knowledge of what the data is talking about, then you use mean, median, or mode to replace. It's good to replace the NaN, non-values data. It's good. But you must have the domain knowledge to do that. If you don't have the domain knowledge, please just remove it.
Okay, all right, thank you.
I will share some data with us after this class. When we are done with this, I will share some data that I myself, I don't have the domain knowledge, but I was trying to do the assignment. So I will share it, and you will see. Some people, I believe some people here have the domain knowledge of what I want to talk about. It's a financial data, which I don't have the domain knowledge. I believe some people are here, so you are going to help me. You are going to tell me some things about it. And I have another one that is about geography. Okay, some people that have the domain knowledge of geography will be able to talk more on such data, but I don't have the knowledge. I don't know what it means. So I just have to research to see what I can do about it. I don't just go and replace. If you just go and replace, you are going to be missing out so many things. So when we are done, I will share it with us so that you will see the importance of domain knowledge. Okay, now here we want to talk about the describe. This is just the statistic of all the numerical data. Luckily for us, this data they are all numerical. There is no categorical data. But if we have categorical data, we can also check the describe. But in case of the categorical data, if you want to describe categorical data, you include, there is a keyword that you say include all or include whatsoever you want to include, maybe the categorical or whatever. So which we treated sometimes when we were running some codes. So, but now since if they are all categorical, fine. So if they are all numerical, so what is it? We may not really know how to check this, but the quickest method, the easiest method to check this is to just look for your median and your 50%. You can see we have median and 50%. We can also look for minimum and maximum. You add minimum and maximum together and divide by 2. But that one is even a lot more. When you say 17 plus 0, that is 17. Divided by 2, that is going to give us about 17 divided by 2 is just going to give us about 7 point something, right? So it's going to give us about 7 point something. So we can consider that. But don't even bother yourself. Just check for the mean and the 50 percentile. Anytime you call on describe, what we are using this to check is the statistical distribution or the distribution of your data, whether it is well distributed, whether it contains an outlier or not. This is how we are going to know if it contains an outlier. If you check this, the mean is 3.84. Let's just say 4. Now, when you check the 3% in 50 percentile is 3. So it's close to 3.8, but not too close. So in some cases, we can say it contains some outliers. Yeah, it may contain some outlier because if you look at the minimum data here is 0, and you check the maximum data here is 17. If someone is telling you that I've been pregnant for 17 times, you can see that the 17 may be an outlier. For someone to be pregnant for 17 times, maybe the person meant to say 7 times. So, and you can see 75% percentile is 6%, is 6 here, which is logical. If someone says I'm pregnant for 6 times, which at 75 percentile, it means at 100% should not be more than, some people will be saying pregnant at maybe 8 times, which will be good. But now see the maximum, instead of being around 8 or 9 or even 10, let's say the maximum should not be more than 10. If you already have 75 percentile here to be equals to 6, then the maximum should not be more than 10. But here we have a maximum of 17, which shows that something is wrong. The 17 may be an outlier. So that is why the 50 percentile and the mean, they are not the same or nearly the same. If you have 3.8 here and we are adding 3 here, it's good. But What about if this one can just be like 3.5, why this one is 3.8? That will be a perfect match. So we are saying your mean and your 50% are supposed to be very close. So from here, I can see that my pregnancy have some outliers, which the 17, I don't want to agree that you want to tell me you are pregnant 17 times. It may be possible, but these are exceptional cases. Exceptional cases. So I can just remove it. I can remove it. By the time if I go and remove this 17 from my data as an outlier, you will see that all this, and I call on the statistic again, it will quickly adjust so that my mean and my 50 percentile will be almost the same. So from here now, from this statistic that I'm saying, under my pregnancy, I'm already saying that there is a possibility of outlier. That is why we call on describe. You can see the importance of describe. That is why when they say, for you to be a data scientist or analyst, you must be very good in statistics. This is actually what we mean by talking about statistics. We are doing some statistics of just main media and mode here. And you can see how great it can be for you to identify something like an outlier. Okay, let's look at, and of course, when you have 768, 768, 768, 768 under count for everything, it's so that it's not having some, it's not, if we have some that has a NaN, all this may not be equal. Yeah, because if it has NaN, and we see it's not even having any NaN. Let's check under the glucose. Let's see. Under the glucose, the mean is 120. Okay. Then where the medium is 117. Yeah, I think it's good. When you have 117 somewhere and you have 120 somewhere, it means it's like it's well represented. It's well represented. Okay? It means the glucose is well represented. But that doesn't mean that there is no outliers there. Because if you check the minimum, okay, some people can have a glucose of 0. Oh, I don't know. I don't know. If your glucose level can be as low as 0, I don't know. I am not too sure of that. If the glucose level should be 0 when you are still living and you don't have any glucose level, then I can say 0 may be an outlier. For someone to have a glucose, that is why the 117 is not exactly the same thing as 120. Okay, it's close, but not close enough. What about if we have something like 120, 119, 120, and they are very close? This is 120.8. What about if I have 120.2? So we saw that these zeros, I can see these zeros may be an outliers because, and if you see the minimum is 0 and the 25 percentile is already 99. So we show that zeros, it should not be a very good glucose level. So there could be some traces of an outliers here, maybe towards the minimum. Why this one may be towards the maximum? Sometimes it can be towards both minimum and maximum. Of course, you cannot doubt someone saying the pregnancy level is 0. I'm yet to be pregnant. You understand? So this one, you may not be able to query someone saying 0 for pregnancy. You can't query me if I say I've never been pregnant before. But you may be subjected to being queried for being pregnant 17 times. I don't know, 17 times. So of course, some people can try. Back in Africa, you have someone that can give back to like 17, maybe 12, 13, 14 children. But I don't think I've ever seen anyone with 17 children. Just only one woman with 17 children. So back to our glucose. So the glucose level of 0, maybe such individual is in I don't know the condition I want to call it, because this is even less than is much more than what can be said to be hypoglycemia. So I don't know. So if someone can have a glucose level of 0, you may have some glucose level that will not be enough, but 0 is too small. It's too small. So that may not be a good one anyway. So let's move to blood pressure. The blood pressure, well, let's see. Under the mean 69, under okay, under the mean 69, under the 50 percentile 72. What? That may be good as well, but it's too far. It's too far. 72 and 69, okay? Maybe they are far, they may not be too far. But I can see some outliers towards the zero. If the minimum is 0 and the 25 percentile is already 62. So what happens to something like 30, 20? So if the 25 percentile is already 62, the 25, if I have the minimum as 0 and the maximum as 122, then like 25 percentile should just be about let's just say 25% of 122. Okay, so which shows that there are some outliers towards the 0 point. How will you tell me your blood pressure is 0? That may be an outlier here. You can see. So these can help us. Now, skin thickness. So I don't know how someone is having a skin thickness of 0, but let's even still check. The mean is 20, while the 50 percentile is 23. You can say none of them they are not exact. They are not exact, which shows that there are a lot of little outliers here. Skin thickness, the minimum is 0, the 25 percentile is 0. So I don't know how they measure the skin thickness. Why some are having skin thickness of 99, some people are claiming to have skin thickness of 0.000. There are some outliers towards the zeros here. Insulin level. The mean of the insulin level here is 79.79. While the 50 percentile is 30. In fact, this is having a lot of outliers. This is insulin level. Because if this is 79 and you have the 50 percentile to be 30, there, of course, see someone saying the insulin level is 846. This may be maybe a mistake. If you are having 75 percentile of insulin level to be at 127, and someone is saying is having 846 as the insulin level, that is the reason why the difference between the mean and the 50 percentile is much. If the mean is 30 and the 50 percentile is 30 and the mean is 79, then there's a lot of outliers here. And of course, from here you can see it may even be just only this maximum that contributed to this difference. If you just go and remove these data points that have 846 insulin level, you will see that this will automatically adjust and lot will be corrected. So there is a lot of outliers here. Another thing under body mass index, the body mass index of the means is 31.9, let's just say 32. 50 percentile is 32. Okay, this is good. The 50 percentile is 32 and the mean is 31.99, which when we approximate this is 32. So this seems to be the best data here so far. The body mass index is the best data so far. However, there is still some little traces of outliers. You cannot tell me your body mass index is 0.00. So it means you have no weight, you have no height. So which shows that 0 as a body mass index is going to be an outlier. So all of them are, but the level of outliers differs. This one, the level of outliers here may be just towards the 0. If you just remove or you just remove those that have zeros as outliers, or you replace the zeros with something else like the main data, then that may correct the body mass index. From the definition of body mass index, if we don't even understand every other one, we understand this one, that it is calculated from your mass, your weight divided by your height square. Now you are telling me it is equal to 0. Then it means you don't have a weight and you don't have a height. So it's not possible. So you can see that there is a level of outliers here. You get a lot from description, don't describe. There is a lot you get from it. From here, we have some feelings of outliers in almost everything, but the level of outliers varies. Let's look at the diabetics and pedigree function. So if the mean is 0.47, let's check the 50 percentile, 0.47, 0.37. Okay. Well, we may not really be able to question this because it's family related stuff, I think. So if you may not be able to question the outliers here, the fact that your family is not having the history doesn't mean that someone's family will not have the history. So we may not, and that is why the domain knowledge is very important. You don't just say because there is an outlier and remove. You don't just say because there is an outlier and remove the outlier. No, that may be wrong in some cases because these are specific to individual. So the age, of course, I can see age of 81, no problem. Age of 81 is good. There may be no outliers here. Let me see the minimum age. The minimum age here is 21. Yeah, it's good. You can't tell me 21 is an outlier. You can't tell me 81. This is age. It's when I put someone now put age of 150, 200, that may be an outlier. Yeah, you are telling me your age is 200, 150, 800. That becomes an outlier. But let's see. Let's still check. The mean is 33, while the median is 29. Yeah, it's good. 29 and 33. So yeah, I think it's well represented. So the outcome, there's nothing you can do about the outcome. The outcome is what we are even looking for. It's our targets. So from here, you discover that there are some little outliers. Then the next thing, when you have discovered there is an outlier, then you correct for the outliers. How do we correct for outliers? Apart from using a bus plot, we have been able to check the outliers without even using any tools. Just through describe, we have discovered that we have some level of outliers, and we can even explain these outliers. Now, we can use some visualization to check the outliers ourselves. If we like, we can use some visualization to check for these outliers. So I don't know, should we check for any, okay, let me see, let's just check for some of these outliers. Let's check for some of these outliers. Let me just copy any of our code, like I've used some of this code before. Let me just use this. Let me just check for the outliers, and let me copy a code that we can use. PRT. Did I? It depends. I think I should have imported all these. This is outcome this time around. I just want to print for a specific one. Let's just print for the f.outcome. The f.outcome, since it's the outcome we are looking for. Let's just call it the outcome. I'm not sure if I've imported matplotlib. Okay, Cbon. I didn't import Cbon. Let's just import. Import matplotlib. Let me import Cbon and run again. Normally, every import is supposed to come first. So, but I will be importing some things as the need arise. What is the name of? Okay, we are using the F. Yeah, it's the F. Why is it? Let me see. Our data is the F. Yeah. Okay, let me see. Maybe I have to rerun. Yeah, the cell is dead. That is the problem. I already have a dead cell. Let me put my data again. When you stay long without doing anything, your data may be dead. Your shell may be dead. Already have a dead shell, so we have to start running again because it's like the shell. Okay, you can see it was not even. I already have it imported. It was because the shell was dead. Yeah, that is the problem when you are using collab and you are not active for some time. It will be dead. So we have run for all these. We have run all these. We have run these. I already imported it. So let me run again. Yeah, it was because it was dead before. Oh, I can't find. Let me see. What am I plotting? PLT? I can't see it. Kind. The hell. What is the problem now? Let me check. So apart from the strike statistic, you can plot so many things. Okay, let me just plot density plots instead of because that one is giving me a problem. Let me just plot for density. I think that should even be what I should plot in the first place. The F dot BMI dot density plot. Let me just plot for the density plot. Yeah, you can plot for every column. The tails is indicating that there is a little, you can see little distortion here, and you have a long tail. It's telling us that there is a little what do you call it? There is a little outliers. So instead of let me check for the one that let me check for the pregnancy. Yeah. Let's see how the pregnancy's own will look like. That one contains a lot of, you can see a distortion here. You can see it's a long one, a long tail towards here. Okay, which shows that you can see the distortion here. It's telling us that there is an outlier. We are supposed to have almost a perfect shape that runs this way. So we are supposed to have a perfect shape like this, but see where the distortion starts from. You can see. So telling us the shape is telling us that the what do you call it? The data is not a perfect it's not perfectly distributed. Yeah. So we can adjust for that. But for this particular exercise, I'm not adjusting. I just want us to run it first and see how it looks like without even adjusting anything. After that, then we can begin to adjust. So now we assume that it's not containing NA, it's not containing an outliers, nothing. The data is clean and perfect. That is the assumption now. So we're going to have our X and Y. All our S is just going to be the old data apart from the outcome. So our S is just going to be that we take everything and leave this one alone because this is going to be our Y. Y, everything from age to pregnancy is going to be our S. Why the outcome, of course, I said outcome is only one. It's only one column that will represent our outcome. Why every other thing may, or some of them may represent our input. So, but in this case, we want to assume everything to represent our input from pregnancy to age. Why the outcome will represent our output. Then we get it out this way by saying pregnancy, by saying S is equals to drop outcome to mean our S, and then the remaining parts, the F when you drop outcome, is going to be our head. And from the head, the outcome alone is going to be our Y. You can get that. You may look at it if you want to check. If you want to check for your S now, just say S and run. It's going to give you every other thing. You can see pregnancy, this, up to age. The only thing that is no more there is my outcome Y, which is already representing outcome. You can check for Y as well. If you just run on Y, it's just going to tell you that you can see everything is Y. This is the only 1, 0, 1, 0. This is the only Y. The outcome is the Y. That's all. If you like, you can check for that. But again, we can check for correlation of our S, that all these data, are they correlated? Do we have any of the data that are correlated? This is the way to check for correlation, which I showed us the other time. You can just check. You can see that all of them, they are less than 1 is a perfect correlation. But if you have something like 0.8, like 0.5, it means age and pregnancy somehow correlate. If I want to set my correlation, let my correlation start from 0.5. It means many people that are pregnant, their pregnancy depends on the age. Like some people, the higher the age, the higher the number of pregnancy the individual have had. That is why there is a little correlation, but the correlation is not much. This is just 0.5. Assuming it's not strong enough. Assuming you have something like 0.8, 0.9, or even 1, that is going to be a strong correlation. But in a way, it's still a valid argument that when someone that is at age 20 can have like 2 pregnancy, while someone at age 30 can have up to like 4 pregnancy. So it's a good correlation. You understand? So, well, you don't, but though someone at age 30 may have 2, while someone at age 20 may have like 4. But from here, the correlation, there is a correlation between age and pregnancy, a positive correlation. Okay, the higher the age, the higher the number of pregnancy. That is what this indicates, because it's a positive correlation and not a negative correlation. So this is the only one that has a correlation in all our input, age and pregnancy. When you check age and glucose, it's 0.3, so it's not a good correlation. When you check age and skin thickness, it's minus 0.1. So it's not even a good correlation. It's still even a negative correlation, but not correlated at all. You can't take this as a good correlation. I will set my correlation, let's say anything from 0.5. But a good one should be something like 0.7, 0.8, 0.9, highly correlated ones. So when you check your age, for example, and diabetes pedigree doesn't have any thing in common. Because zero correlation between age. Doesn't matter whether your age, your history remain your history, irrespective of your age. Your parents remain your parent, irrespective of your age. So the history remains the same. I think that may be the reason why this is giving you 0 correlation. So these are just, by the way, these are just a visualization to get more in-depth on my data. Now, after getting my data, my S and Y, the next thing is to split. So when I split, of course, you already know how to split. You will call on this from sklan. Of course, we discussed our sklan the other time. There are so many libraries that are in the sklan. So this is one of them, and we splitted it. So if you are taking the test size to be 20%, it means the training size is going to be automatically 80%. So we are training with 80% and we are testing with 20% of the data. That is what this means. You can set it to 30, 0.3 if you like. So, and the first model I want to build, of course, the first model is I'm using Gaussian and NB. That is what I'm using. So when you call on the model, declare your model. If you like, you can call on logistic regression. When you call on the model, the next thing is that you fix the model, or you say you train the model. So when I call on that, this has fitted the model for me. After that is to predict on the model. So when you call on predict using the S test, you predict the model, and then after you predict the model, you check on the metrics. So checking the metrics we are checking on are accuracy, recall, F1, but the common one we used to understand is the accuracy. The accuracy of this particular model is 0.76. That is 76.6%. Let's just say 77%. So, which is a good model. It's having a 77%. And the loss is high anyway. The loss is 8.4, which is a very high one. If there is a way we can prepare and have a higher accuracy with a reduced loss, that would be better. So this model is already having 0.766 as an accuracy. So if I assume that this model is good because the precision is 0.83, the recall 0.80, the F1 is 0.81, and the support is 99. But there is something under this report. When you check the report is, the first thing under the report is this, you can see. But you can see the report, there are two values under the report, 0 and 1. It performed better on 0, but did not perform well on 1. The precision under 0 is 0.83%, which is good, while under 1 is 60%. Anytime it sees anything 0, it can classify it very well because it's already 83%. Even if you check the record, it's 80, and this one is still 71. If you check on F1, you can see 0, the class 0 is 81, while the class 1 is 68. It's not very good. And under the support, you can see that the support for 0 is 99. The one that have 0 class and the one that have 1 class. No diabetics and one which means diabetics. It performs well on people that doesn't have diabetic than people that has a diabetes. Why? If you check, by checking the report, the performance on people that doesn't have diabetics, the model perform well on them compared to people that has a diabetic. The reason is because our data is small. And when the data is small, sometimes, apart from being small, if you check for the data of what we are using to predict, you will check for our outcome. It may not be evenly distributed. For example, out of the 700 and something data that we have collected, it may only be 400, 700 and something data. It may only be maybe 200 plus or 300 plus that has diabetics, while the remaining of more than 400 will not have diabetics. So it means that the model will see more of the people that doesn't have diabetes more than people that has diabetes. Let me explain in a literal way to make us understand better. If we have a class of like 100 students, and then, or maybe 100 human beings, for example, and you see out of this 100, you have 70 of them, or let's just say 80 of them, they are female, while 20 of them are male. And you call on an animal and say, okay, I want to train this animal to recognize male and female. Immediately you see this and say, this is a female, this is a female, this is a female. Okay, when you tell the animal, this is male. And remember, you only have 20 male here and you have 80 female. It means anytime you bring any female, the animal will be able to recognize it because this animal has been trained more on female than on male. The same thing is what is happening to our model. Anytime the animal sees male, the animal may be confused to say the male is female because the animal was not trained enough, was not being trained enough on male species. So the same thing is what is happening with our model. We can check. If we call on let's just call on our outcome.count values. We want to count the values. You will see. Let's see count values. So you can see the 0, in fact, 0 is 500. People that do not have diabetes. and people that have diabetes is 268. So you are using people that have diabetes of 500, that do not have diabetes of 500 to train a model, and you are only using 268 to train the same model. It's not going to do well on the people that has diabetes because the training is not equal. What we should have done is like the way when you have about 768 data, we should have just divided it into two. Out of the 700, let's assume that 350 it was used to train when the 360 or 350 has diabetes and the remaining one did not. It may not be possible for us to have equal amount, but they should be close. The way we have 500 non-diabetics, assuming we have something like 400 and something diabetics to train, this model will perform better than this. That is the reason why it's performing well on those people that did not have diabetes. Imagine, see the metrics: 83, 80, 81, 99, and see the metrics of this: 66, 71, 68, and even 55. You can see it's not the same. The reason is because this data is imbalanced. We call it an imbalanced data. We call it an imbalanced data. And when you have an imbalanced data, it's a big problem. So we're going to talk about it later. So, but let's just assume we already train our data and we already train our model and we have the accuracy of 76%. So when we call on the confusion matrix, you will see that it will be able to train. Now, it was when it was 0, it was able to confirm 79 zeros, and when it was 1, it was able to confirm 39 ones. But when it was 0, when it was 1, it was still confirming up to like 16 zeros when it was 1, and when it was 0, it was still confirming up to like 21. These are just the performance of your metric. Of course, I told you the other time that this diagonal is what we are looking for to be the best. Why this one we make them as low as possible? This is 16, why this is 20. If we can get a model that will give me something like 2 here and 1 here, or 3 here and 5 here, then the model will be one of the best model for this particular data. But for now, let's assume we have 77, or what do we have? 70 accuracy of 77. Yeah, 77% is good. So that is it. Again, earlier I said before we train our model, immediately we split it, that we should convert it to an array by saying s.values, y.values. I said it's not compulsory. But if you do it, fine. If you don't do it, no problem. When we convert it to an array, we want to use another. I just convert it to an array. It's not necessary. So I want to use another model. I have another S-train. Okay, before then, let me convert it to an array. I didn't run it. I have another S-train and Y-train. And this time around, I want to call on different model. I'm calling on logistic regression this time around. I will fix it at the same time. It's different from the former model. So this one is logistic, while the other one is GB, while the other one is GND. This one is logistic. So we want to see the one that perform better from the logistic and this other one. So if I run this, predict, I run this, because one of the things we can do is to keep changing our models. Choose another model again if you think this one did not perform well. Choose another model again if you think this one did not perform well. So after choosing this model, let's see. Oh, the accuracy of this one is 74. It's not performing. The accuracy is not even as good as so it means the former model is better than this model. But all in all, they are all performing above 70%. So let me assume that this one, assuming we run this one first and we use the other one, we think that the second model is better than the first model. But now the first model is better than the second model. You can see almost the same when it comes to the reports. So almost the same. So no problem. Now I want to call on another model again. Okay, no, not even on another model. I'm thinking, let me scale let me use scaling techniques to see if I can get an improved model. So I have scaled. Of course, I told us that we have different methods of scaling. We can use min-max, we can use data normalization using L1, L2, and then we can use scalar and standardization. Those are the 4 techniques we talked about. So I want to scale this time around. And during my scaling, excuse me, with my scaling, I want to say that you can see when I was fixing this model, I'm still using okay, I'm already using this model. Let me see the model I'm using. I want to use rather. Okay, the first, okay, I call this one AR, model AR. That is logistic regression. Means I still want to use logistic regression. But this, when I was training the model, I use X train and Y train to train the first logistic regression. But this one, I don't want to use X train and Y train. After I have declared the different scale, I have new X train scalar for them. I will be using that one to train it. So let me see. If instead of using S-train, I want to use min-max as my S-train, the one that has been scaled using min-max. So if I run it, know that this one is on min-max. Let's see if there is a little performance. This is now 7 points. Okay, 75%. Okay, we initially, after I scaled it, initially before I scale it, I get 74. Okay, approximately 75, but okay, 74.67% before scaling. But after scaling, out of the scaling, I call on min-max. If I call on every other one, it may perform better, it may not perform better, but I only want to use min-max. If I want to use any other one, I will just cancel it and turn it to the train of that particular one I want to use. So, but when I call on min-max, it has improved 75.32% from 74.6 something percent to 75. You understand? This one has performed better. So sometimes if you scale, there may be a better performance, but it's not automatic. It's not as if every time you scale, you have a better performance. No. But sometimes when you scale, there could be a better performance. So that is all about the scaling. I just try to scale to see if my model on logistic regression can improve. The same way I can apply the same scaling to GNV and see whether it's going to improve or not. So it may improve, it may not improve. Those are the things we begin to do. But now, I still have another method I want to use. We have never used this one before. So this is TensorFlow. That is another model using TensorFlow. So if you want to use TensorFlow, there are various ways of building TensorFlow model. Keras, they are using Keras on top of TensorFlow. So it's another model in machine learning, majorly when you are talking about a neural network. So you can use it to sometimes neural network basically for image classification, but you can also use it here. So this is the input. This thing is the only thing that there is a way to build. So I am not going into that. If there is a time that we are going to have any other program, we may just call that program maybe just 2 hours program and just look into how to build a neural network model. So this is just a neural network model that just simple model that you will understand what all this thing means. But the only thing I think you will understand from here is me putting 8 here. It's because I have 8 features. This thing can change. If I have like 10 features, I will put 10 features there. Okay, the features I'm using for my S is 8. Initially everything was 9, and out of the 9, I use 1 output as my Y, so remaining 8. So that is why the input becomes 8. Okay, if you are using another data that have an input of 10, you are going to turn it to 10. If the input is 17, you turn it to 17. Every other thing can remain the same. So, but this is just me trying a model. So next time we can have hour, 2 hours on how to build a model using Keras TensorFlow for neural network. So don't really bother yourself about this. But checking this neural network is not even performing well. It's having on the accuracy, you're having 0.5 and 0.577 on the validation. And okay. I also have 0.68. The maximum, the best one here is this, that has 71%, which is not even as good as the other statistical model we are using. So this is not a good model, though there is a way I can fine-tune it. I can continually changing so many things here. If I change so many things, I can change the loss, I can change the optimizer, and so many other things like that. The activation from ReLU, I can change it to something else and like that. So many other things I can do to see if it's going to perform better. I can add more layers to it. You can see me saying model.add, model.add, there are different layers I can add. I can add more layers to it to see whether it will perform better. I can run more epoch. I think I was only running 10 epoch here. So I run 10 epoch to see. I can run 50 epoch, 100 epoch to see if there is an epoch that will perform better. So that will give me a better performance like that. So that is another model I tried, which is not a better one. So the reason why all this is like this, I've discussed that, is because the model, the outcome of the model outcome is not evenly distributed, as I've said earlier. Okay, if you call on the outcome.com, you can see the 0 is 500, while 1 is 260. It means this thing is an imbalanced data. That is why it's performing like that. Assuming it's a balanced data, it has the opportunities to see almost equal 0 and equal 1. It's going to perform better than this. And another thing I see in the data is that the data contains some outliers. If I can clear the outlier, I think it's going to perform better than this. I've mentioned 2 things now. Number 1, ensure that I have more representative for my 1. 0 is already having 500 representative. Why don't I just ensure that I have more representative of 1? So that can make the data to perform better. Another thing is that the total rows I have was 768, which is more to program to model a 9-column data is not enough. So what about if I produce more data, like let's say 1,000 data and 2,000 data, then it's going to be, I'm going to have more data to train. So that is number 2, what I can do to get more better outcome. Another thing I can do, number 1, I say I should have more representative. Number 2, the data volume is not enough. I should have more data volume, better than 768. Should be like maybe 2,000, 1,000, 2,000, 3,000 data more. Another thing I can do is to remove the outliers, because I already see the traces of outliers. If I remove the outliers, it may perform better. Another thing I can do, I can keep trying different models. It's like I've tried up to like 3 models now. I've tried using Keras or top TensorFlow to build a neural network. I've tried Gaussian, and I've tried logistic regression. I can try every other model to see whether there will be a model that will perform better. So, okay, I just try to print this. Yes, the output, the outcome. This is the outcome, distribution of the diabetic outcome. You can see 1 and the 0. If you check the graph very well, you will see that the 1 is higher than the 0. It should almost be at the same level so that they will have equal representative. So this is an imbalanced data. It's not balanced enough. So assuming the 1 and 0, they are almost at the same height. Now there is a way, there is something we can do. There is something we call oversampling and undersampling. The undersampling is that this one that it is 500, I will reduce it to like 300, so that it's going to have the same thing, almost like that will be almost the same thing as 1. Or I will just reduce it to the same level as 1. That is 1. That is what we call undersampling. You can have oversampling. Like you have this, your one that is at this level. What about if I synthesize another, just ask the machine, the model to synthesize another data on its own to meet up. Majorly those ones that you focus on one to meet up to around that 500. You will see that it will upscale the one with the lower, which is not represented well. So we have undersampling and oversampling. So there is a way we do that, which is something we can still do to increase our the model efficiency. So now continue. We already understand. Now, what I want to do here, I want to use oversampling. I say, okay, to manage the imbalance, because I already know there is an imbalance. The data is imbalanced. Number one, I know the data is imbalanced. Number two, I know that the data, the amount of the volume of the data is not enough. Number three, I know there are some traces of outliers. If I clear all this stuff, then and number four, I can scale. Of course, I've already scaled some. I can scale the data. If I scale, those are things I can do to increase the performance. Let me just use oversampling. This is the way to use oversampling. There are these are things we still have to know, but we can't know everything at once. The more you practice, the more you know. So this is a library that you can use to do oversampling. So you say from imbalance.oversampling import SMOTE. What it means is synthetic and minority oversampling techniques. So if you import these libraries, so importing the library will help you to perform some oversampling. And when you import the libraries, the next thing is to use your split S-train, Y-train that has been splitted, is to redefine them to the one that have been oversampled. Okay, so you now say S resampled, Y resampled. You can call it anything. You may call it S-train of oversampling, or just call it anything. In fact, I even love to call it S-train sampled. I've just pulled sampled, or maybe over. Sometimes I put under. So I just use anything you like. So, but all you know is that you are changing your S-train and Y-train. You want to change them so that they have the same number of the representation or representative. So if I run it, it's going to create, instead of using S-train and Y-train now, I will no more be using S-train if I want to be using the one that has been sampled. So I will be using S resampled and Y resampled anywhere I see S-train and Y-train. So if I run this to predict, I run this to predict, it has done my prediction for me. Okay, no, not yet prediction. After, all I did here is just to put this one in the data frame to feature it again to see the number. You can see this one that was low before, the other one was at 500 before. And why the other one, you can see the difference between the two. This one was 500 before, while this one was around 300 before. So we are saying, let's make them to be equal. So we just remove like 100 from this place and put it on top of this one so that they are almost equal. So they have equal representation. So this is it. They are almost like 400 now. So since they are almost 400, they have equal, it means the model have access to equal to see equal stuff, to see equal diabetics and no diabetics. So now, if I run a model, I want to run my first model, I want to rebuild the model using, instead of using, that one I use S-train and Y-train, I'm no more using S-train and Y-train. And when I train that one, I think we get 77. Yeah, let's check, let's go back. The first model we build. This is the first model. Yeah, this first model where I use S-train, Y-train. We no more we want to use S-train, Y-train. We want to use S sampled and Y sampled because we have done the sampling on it. And then when we run that first one, we got 0.7, okay, 76.62. That was what we got. 76.62. But now that we are using sampled, we are now having more representative. We want to see, would there be a better change? Would there be any significant difference between when we sample it and when we oversample it, or when they are the same, when we use it normally? Would there be any significant difference to see? Okay, so I've run this everything in one, so to see the performance. Oh, I have 0.73. It's not a good performance. I don't think it's performing better. I don't think. 73, the initial one was 0. What? The initial one was let's check, 0.76. So it's not even performing better even after. So what all this thing is telling us is that there are so many techniques you can use, but it is not as if it is automatic that when you do it, it's going to perform. But let's see if we do it on the second one. Okay, I didn't do it. It's not performing well, but I want to run another thing again. I want to, after sampling it, you can see I use sampling. After sampling it, what I want to do is that after sampling it, let me now do min max on it again and see what will happen. So I'm just using different combinations. So those are different things we can do to get a better model. I believe we can. Now I want to call it on a logistic regression. The Y sampled and then the S train min max. I want to combine the two and see whether I will have a better performance. This time around, I have 71. It's not performing well. It's not performing better better than the former one. So I still want to try it on this and see. I'm just trying different models, different things on the model to see if I will have another one and it's something that will perform well. It's not performing well at the same time. It's not performing well. So at that time I was thinking, is there any duplicated value? Because sometimes if we have the duplicated values, you may be having a poor outcome. But I checked, there was no duplicated value. I was thinking on doing some other things again. Like, okay, let me check for there are some of these models that have a parameter called weightage that you can set something that is called class weight. So I want to try another thing called class weight. So I'm thinking like, okay, let me set a class weight to a balanced and try to do some other thing. It's still looking for optimization of my what do you call it, my model. So after using this, I want to check for my logistic, a random forest classifier. So there is another model called random forest. So I want to use random forest, but in the random forest, there is what we call class weight. So I want to improve the class weight. That is what I just did here. Everything that I've done here is just to improve the class weight. After that, I use the class weight in the random forest because I told you there are some of the classifier that instead of saying random forest, we can say random forest and put quote in the front without anything in it. This one takes what is called class weight. So, and there is a way you can go about the class weight to ensure that it performs better. This is what had just been done. And this time around, I'm calling on entirely different model, which I call model beta, or I could have called it model random. Let me call it model random forest classifier. Yeah, let me call it modern random forest classifier because this is another classifier, random forest classifier. So if I run it on random forest classifier, I want to be sure everything is having random forest. Yeah. Now, if I run it, after running it, I got a good model of 0.73, 73 accuracy. So it's not performing better, but let's just assume that it's 73. The best model so far, I think, is the first one that is giving me about 74. So I've not seen any other model that is performing better. So now let me just assume that this is the best model that I want to use. I have tried enough, and this is the model I want to use. Now, someone was now asking that after we have gotten our accuracy and we we are done building our model, what else can we do with the model? I said you can deploy it. You can deploy your model. When you deploy your model, there are people that can help you to deploy the model if it's going to be on web, if it's going to be on app or something like that. So, but I also said you can check it on your system. No, that one is not on production. If I check something on my system, nobody is going to use it on my system. I can only be the one that can use it on my system. But at least let's use it on our system. So if you use it on our system, putting it on API, I think there are some API that you can submit it to, and they will embed. I don't know if you have to pay or something like that. There are free ones where you can use to launch it or something like that. So that is another aspect. It's not your aspect as a data scientist. This is where your job stopped. You build a model, do anything you can do to get a best model for yourself. Try different stuff to get a good model or the best model for yourself. After you have gotten that, then that is the end of your work. You can only save that model. When you save the model, you save the model somewhere. There is a way to save model. So if I want to save this model, I will save it, because if I want to reuse it, I will just call. I don't need to do all this thing again. I will just call on that model alone. I've just called on the model. But now that I'm not even saving it, I can as well still call on the model. Since I'm still on the same Jupyter notebook, I can call on the model and use it to predict. I want to use this particular one to predict. So let's see if we can use it to predict. Before we predict, we must have a data that we want to predict on. I want to assume that I just assume that I want to predict on this. I want to create a new data. Something that you predict on, or you want to predict on, must have all the features. Like, let's just call for s.features. Dot columns, yeah, dot columns. If I call on s.column, you remember our s is the features, right? So if I call on s.column, it's going to tell us all the column we have in our s. So, these are all the columns that we predicted on. Oh, I can't find the s again. Index object is somewhere here, so maybe. Okay, maybe I call it S-train. I don't know. S-train. S-train. I don't know. I think let's call S-train first. I think that is where S-train.column. If I don't know, I should have checked it when I was
Yes, absolutely fine. Hey guys, Abdul, sorry to interrupt.
Yeah.
I've got a 1:30 Zoom. And so can we conclude within the next 30 minutes?
Yeah.
Yeah. So
Yeah. It's just to
that
check.
should be like 2 hours, because obviously I know that I
took
up some time at the beginning. And I'm sure other people, oh, my camera's not on, sorry. I'm sure other people got other bits to be getting on with. So look, amazing. Everything from today is going to be on the website. If anyone's got any questions, please voice them. But we'll be wrapping up at 1:30. I'll be on. I'll get back on here about 1:25.
Okay. Yeah. So we are using the features. I'm trying to search for the features. I can't find it again. But if you just go up here, I should have searched for that initially. You can see that it was all these from pregnancy to age. Okay, I think it was the F. I don't know. I can't recall. If you call, the only thing that will not be in the S is the outcome, because that is what we want to predict. So now I want to create a data and say, okay, what about if I have someone who's maybe you may predict for individual, you may predict for a data. Okay, let me predict for, okay. I created another new data frame. Someone that has 3 pregnancy, 126 glucose, this and that. I created a data frame which I call new data frame. So if you call for that new data frame, you will see that it's already creating it's already creating a new data frame for us. So someone with 0, what do you call it? Pregnancy, glucose level. Okay, someone with 3 pregnancy, glucose level of 126, blood pressure of 60, skin thickness of this and that. Tell me about the outcome. You know, this is what we have built a model that should be able to tell us what the outcome of this will be. Now, that is the next thing we want to do. I now reason that, okay, what about if you have multiple? The first one, I just want to create more. I want to create like three rows. Okay, this is the new data I have now. This data is not having the outcome. It is the outcome we want to predict. I actually got this one from the second row of what we used to build, and I think it was 0. The outcome was 0. I know of this, but this other two, I don't know them. It's something I just put on my own. Or maybe if this is me, my pregnancy, I have 2 already, 2 pregnancy, my glucose level is this, I want to predict on myself. Maybe my blood pressure is this, maybe my skin thickness is 40, my body mass index, and my BMI. This is my diabetes pedigree function, and this is my age 27. Maybe if I can still ask some other people, okay, let's see someone which has a age of 50 and an age of 35, and someone with this. We can add as many as possible in these libraries. If we have to this dictionary rather. When we have to this dictionary, the more we have to read, the more our data keep on increasing. And let's just predict on this 3. The only one I have answer for is the number 1. Is the one on index 1. That one I copy directly from the second column of the initial data. This is the initial data. This is not. Let me check. This is the initial data. You see this second column, right? I copied it. Of course, the outcome is 0. We already know that the outcome is 0. So that is what I want to mimic. I say, okay, I have others that I don't know, but this one I already know that the outcome is 0. Let's see if the model will still be able to predict for me that one is 0. That was why I put it there. So normally the model you are going to predict on the data you have never seen before. So fine, I've seen this one before, but the other 2 I've never seen them before. It's the one I just created by myself. So now after I run this is a new, I call it the F2. Now after that, the next thing I will do, I will just call and say, okay, I will just call a prediction. You can call this one anything. Predict, you can say predict for me. Predict for me, or you call it prediction. I'll say prediction or predict for me. Anyhow, call it anything. Predict for me. So let's just put it like this. Predict for me. So if you say predict for me and you call on the model, you know, the model, I didn't save it. I can save it if I want, but I didn't even save it because I already have the model with me here. I'm still working in the same Google Colab. And the model, I call it the model, the last model I want to use. Assuming this is the model I want to use, this is the name of the model. Model logistic, what do you call it? RFC. Model RFC. If I call on this model RFC now, the model RFC should be able to predict for me. So let me call on that. Where is it? Okay. This is it. I'm saying the model should predict for me, but the name of the model I'm using is logistic random forest classifier. If I like, I can use the first model I built, which I just call model. If I like, I can use that one. That one, I just call it model. So depending on the model I want to use, and I want to predict on this new data frame I have. But one thing you should note on this new data frame I have is that the data frame contains only the thing that was used to build the model. You can see, it contains only the things that was used to build the model. So that is why it can predict. If it contains extra things, then it will not be able to predict that. So I run it. Now I say it should predict. If I say it should predict, oh, okay, I'm not having prediction again. I already call it predict for me. So it has predicted it. Okay, run this prediction. It's telling me it's 100. Of course, I know the second one. The second one is 0. I already know that this second one from the original data is 0. If you go and check the number 2 of that original data, you can see it's 0. So if it's predicting that number, this one, which is also number 2 on this, on the I provided a new data for 1 and provided a new data for 3, but this number 2 was the data I have originally that I just copied. So, and it has predicted it, and it's telling me that that number 2 was still 0, which shows that it's performing well under the prediction when I was using it now. So now, how am I going to get it back into data frame? I have run prediction on it. I've run prediction on it. Let me see. Okay, I've run prediction on it, and it's telling me the output. The output is 100. So I want to make the prediction to be a data frame, in a data frame, which I call predict for me. Put it back into the data frame of number 2. So if I run it, I want to get a new data frame that will now contain prediction. So if you check the prediction, it's just going to, so the number 1 is telling me that this particular individual will be 1, and this particular individual will be 0, and this particular individual will be 0. Let's assume another data. Let's just go back and update this. Let's assume that the pregnancy, this individual has a pregnancy of like 8, and glucose level of like let's say 30, 38, and let's say the blood pressure, let's say like 70, okay, 67. Let's say like the thickness, let's say like 23. Let's say like the insulin level, let's say like 66. Let's say like the BMI, let's say like 45. Let's say like this pedigree, I don't know, let's just put 1. And let's say like age, let's say the age is maybe 60. Okay, if we run it, it's going to include that one to our data again. Let's run and see our data will contain like 4 data now. So we run this. Okay, it has updated it. So we now have another one that have an age of 60. So let's see what that prediction is going to make on this individual with this particular data. If I run this, okay, it has predicted it. And let's run predict for me. So it's saying that individual is 0. So it's also predicting 0 for such an individual. So we run, it has updated it. That is how we can continually make a prediction. You can run another thing depending. So now we have been able to build a model, use any of the model, even from the point of building the first model, even without doing anything. We can start making our prediction after this first model that we built, and we already have 76. So this model is even good. It's already 76. So I can start making prediction from here, from this 76. After this 76, I already have the model name. I think the model name is just model. So I can just call for this model. Okay, the model name is just model. So you can just call on this model using all this data the same way I have it here. You can just call for this model here. Let me just copy. Let me call it predict for me. Let's come and predict under that first model. Assuming we are using that first model, which is even a good model. Every other thing we were doing after the first model is just to see if we can get a better model. But since we didn't get a better model, it even seems like the first model is even the best model so far. So let me predict using the first model. Let me just say predict for me too, because it won't be, I don't want it to be the same name. Or let me just call it predict. And then this model is now going to be model. So the data I'm using, this is the data I'm using. Let me declare the data from up here, since I'm using it here. In case, so that when you are working alone, you may not know that you have not run the data, so you may make mistakes. So that is the reason I want to copy it up. So I copied it. Let me bring it to where I want to make the first model, where I build the first model. Yeah, this is let me run for the data. This is the data. I have the data here. So after having the data, you can run this to see the data again. So we have seen the data. After seeing the data, we want to predict on the data, and we say predict is equal to model. The reason why you are using model is because the name of this particular model is called, we just call it model. So if I run it, it's going to use that particular model to predict. Okay, it has predicted it has used the model to predict. After using the model to predict, what else? Okay, I can call for my predict. Let me just call for the predict. No, instead of copying, it's now far. So this is the prediction. So this is the prediction. 0.04, 0.08, 0.00 is using it as floats. So this model did not convert it to a whole number. So assuming it has been converted to a whole number, then this one will be, it means everything this model has done is convert everything to 0, because there is no one that can be approximated to 1. This one is 0.042. This one 0. This one should have been 1, assuming, okay, if I multiply it by 100, no, it's not going to be 1, because this one is 0.08. Assuming it's 0.8, now I will have said it's going to be 1. So the prediction for this is different from the prediction. The way this one predicts is different from the way the other one predicts. And it's not the only one that will be assumed to be 1 is the one that is close to 1, that can be approximated to 1. So that is the way this one is making its own prediction. Okay, so that is a different level of prediction. We can ask it to approximate to the nearest whole number, but the way we are seeing it, everything is 0. So the prediction of this is different from the prediction of the other one. Of course, this one performed better than the other one. So that is how to make a prediction. Now, apart from all this method which we are using, there are other methods we can use. We can just, okay, that is what I just want to run through, because it's very difficult for us to just finish everything like that. But let me run through this so that you can, in case you are reading, there is what we call an inputter. So the inputter is like a circuit, is, in our circuit LAN. I told us that in our circuit LAN, we can do, and we can choose a model. In our circuit LAN, we can do this feature selection, we can do processing, we can do so many things in our circuit LAN. Some of the things we can still do with a circuit LAN is to do an inputter, and to do feature selection. So, and the other time we were using scalar. We were scaling our data using standard scalar, min, mass, using every other things like that. There is a way we can do it without doing it manually. We could have done it like we automate it. So instead of doing everything manually, like we want to fill for missing value, we can automate it. This is the way to automate it instead of using the normal approach we were using. So assuming there is a missing value, this is how we are going to automate it, instead of using the method of checking each column and each column and the inputting whatever I want to input. This one, we just check all the columns, and then at the same time, after checking all the columns, it's just going to strategy I want this one to use. Any missing value it sees is going to fill it with what do you call it? With main. If it is mode you want to use, you use mode. If it is media you want to use, you use media. It's going to do it directly for you. But anytime you want to use this method of automating whatsoever you have, you must have done your S train and Y train. you must have divided your data into S-train and Y-train. So if you have divided your data into S-train, of course, the first data we first did, and we have S-train and Y-train, is what we are using now. It's what this one will call for. Say, okay, where is the S-train? Any S-train it can see in this column, which was the first one, it will call for it. Except I just want to declare another one here, which is not necessary. If I want to declare another one, I can simply just come here and say S-train, Y-train, and say this. So it's going to be seeing this S-train and Y-train. So after that, it's going to check in the S-train if there is any missing values, then you're going to put it, you're going to input it and do it automatically. If there is anything that needs to be scaled, it's going to look at it and scale it automatically. This is an automatic method of scaling, automatic method of filling NA, an automatic method of removing outlier. It will just check everything from in your S-train and remove the outliers, S-train and Y-train, and remove the outliers from it. So if I run it, it will do it automatically. And this one is also a feature selection. It's not compulsory. In the case of feature selection, I want to say, don't use all the features, it was 9 features, and out of the 9, 1 was an output, remaining 8 features. If I say don't use 8 features, use the best 5 features that you think is best. So you can change it as you like. I use 5. If I like, I can use 6. If I like, of course, it's supposed to be 8. Out of the 8, I want to use 5. So it's not compulsory you go through all the method. You can remove this from whatsoever you want to automate. You want to automate and use every other thing. So, but since I want to just select any 5, I run, it's going to select just any 5. And the 5 is saying that, it said the best 5 is glucose, insulin, BMI, diabetes and pedigree, and age. That they are the best to use, that they are the best that are used for the prediction. So all these things have been done automatically. It has scaled it automatically. It has removed outlier automatically. It has everything. If you want to do anything automatically, this is the method you use. But the problem with this method is that before you do it, you must split your data. If you don't split it, there is what we call data leakage. If you don't split it to S-train, S-test, Y-train, Y-test before you begin to input. And instead of putting it on S-train, you are just putting it on the head, everything on the head. After you have done everything, now you now come and split it into S-train. The model will perform very good because the model I've seen is like you are giving the model hints of all the data that are present. That is what we call data leakage. So the data will have linked. So, but now if you do it this way, there will be no data leakage. Before you can automate, you must split your data. Before using any inputter, you must split your data. That is the only precaution here. After you have done that, it's not compulsory you do feature selection. If you don't want to do feature selection and you want to go and predict, the only thing you will only take note is that your Y-train here was called Y-train no outliers and S-train no outliers. That is the one you are going to be using. It's not going to be S-test RFE, S-train RFE. All this one will not be in your training data because we have automatically changed our S-train and Y-train to S-train RFE. We have automatically changed them. But if you stop at this point, these are the things you will be using, not this. So you should take note of whether you are doing feature selection or not doing feature selection. So now if I run this pipeline, this one will do everything again. When you run the pipeline, it's like you are automating everything. This is another thing we call grid search selection. It's going to check some criteria. There is a way there is a way to choose the best model. So this grid search selection will just search for some things and choose the best model for you. So when you run it, it's going to give you a better output. So this is not what we can go in depth into, but the best thing I know now is that we have already been able to train model. We have already, so after we have done everything, we get 77, which is better than the first one. Even with everything we have done, it's just 77. And the former one, we still got, I think, 70, I can't remember. So this is just 77, even with everything we have done. But at least there is a little improvement. There is a little improvement. So on our accuracy, 77, 77, 77, 77, F1, accuracy, precision, recall, they are now all 77. So which is still a better model. But I've been able to address the question of asking, like, after building our model, what do we do with the model? You can test the model on your system. But if you want to go beyond your system, that is something that is beyond you. I don't know if you can go and buy the API, maybe it is sold, or maybe there is a free one, or there's someone that knows how to build an app or a web that will include your model in it that it can be used. Because the one you check on your system, it is only you that can check that on your system. So thank you. This is how far we can go, and you cannot know all at once. This is just a baseline for you to build on. Try to attend different seminars and so many other things to see, like, you improve yourself every day. Even I myself, I keep improving myself every day. And this is even just only on tabular data. There are some other data that are not tabular. So you have to also know how to work on image. You also know how to work on text and so many other things. So you keep improving yourself every time. Thank you.
Thank you so much, Abdul. I've learned so much. So much I've learned.
You are muted.
I hate that when I do that. Yeah. But I was saying, honestly, Abdul, thank you so much. Amazing. I'm working away listening all the time, but I've got so much stuff to get done. But yeah, amazing. Thank you everyone for taking part. I hope everyone's got some value out of it. I think you did, which is great. Everyone's going to be getting a certificate for completing the first BDPN Data Science Academy, so Series 1. So thank you for being the students for the BDPN. We want to continue this journey, and we're doing what we can to make it more beneficial for everyone that's Black, that wants to progress their career in data. So if we can be a part of that journey to make it happen for you, then that's what we're going to continue to do until people tell me to stop. So yeah, certificates will be out in a couple of weeks. There'll be electronic certificates. And yeah, I just want to say thank you all. Do you know what I mean? So yeah, that's it. If anyone wants to say anything, please do.
Ian, yes, thank you for putting this together. You know, this is a good initiative. I really, really appreciate it. And continue doing the good work.
Yeah, I'm going to try, man. Do my best. Definitely. All right, fantastic. We're going to end it now. Everyone have a wonderful weekend. Take care of yourselves.
Okay.
Thanks, Abdul. Speak soon.